Come to class. In one of my videos on logarithm, we try to introduce ourselves to what logarithm is. So this time around, we'll be looking at the laws of logarithm. But before we go there, let's quickly remind ourselves of what we did during the last class, which is on logarithm. We talked about, we said logarithm, I said logarithm to base A of a number P is the index X to which A must be raised to be equal to P. And we try to clarify the difference between index form and logarithmic form. So today, we'll be moving to laws of logarithm. As you can see, let P equals B raised per S. P equals B raised per S is which of the form? Is it an index form or a logarithmic form? Yes, it is an index form. Same with Q equals B raised per R. Now, when we are going to write it, or in order to write it in logarithmic form, it will be log P base B equals X. Same applies to the second one, log Q base B equals Y. Now, let's go to the laws. In the laws, we have 5 laws. For me, I call the first law the product law, the second law the division law, the third one, I call it the law of raised to power. That's what I call it. Then I call the last one zero law. So let's go to the first law. When we have P multiplied by Q, it's written as P dot Q. The dot means multiplication. So what is our P? From here, our P is B raised per X multiplied by our Q is B raised to power of Y. Now, both of them are having the same base. In the law of indices, every product will turn to sum, addition. So B, you take one of the base, B, then X plus Y. Now let's write it in logarithmic form. To be log of PQ base B equals X plus Y. Let's go to the second law. Division. P divided by Q will be B raised per X divided by B raised per Y, which will be equals to, you take one of the base, then X. Every division in law of indices, it will turn to subtraction. So X minus Y. X raised per X minus Y. B raised per X minus Y. So log of, instead of writing P divided by 2, you can write P over Q base of B equals X minus Y. Let's go to the third law. P raised per N equals B raised per NX. Sorry, don't let this confuse you. Let me write it closer. P raised per N equals B raised per NX. So log of P raised per N base B equals NX. Therefore, this N cannot be here. So you bring it out to the back of log. So we have N log this B, let me reduce it. N log of P base B equals NX. So let's go to the fourth rule. B equals to B raised per 1. So that would be log of B base B equals 1. So when you see log of 10 base 10, it will be equals to 1. To the last rule or law, we have 1 equals B raised per 0. Remember, I used to mention in my video, even when we were doing binary, anything raised per 0 is 1. Either an alphabet or a number raised per 0 is 1. Now let's write it in log. Log of 1 base b equals 0. We'll move to some examples on this. Example 1. Solve the following logarithmic equation. The first question, log of x squared minus 2x plus 5 base 2 equals 2. The second question, log of x squared plus 15 base 4 equals 3. Now let's start with the first question. Now the question says log of x squared minus 2x plus 5 base 2 equals 2. Remember, this question is in logarithmic form. We want to take it to index form. How do we do that? The base will be raised to power the number in front of the equals to, then equals to this. So let's try it. This x squared minus 2x plus 5 equals to 2 raised power 2. And what's 2 raised power 2? That's 4. Now, this has turned to an equation and we need to solve it out that way. And how do we do that? You bring 4 to the side, the left hand side, everything will be equals to 0. X squared minus 2x plus 5 minus 4 equals 0. You continue. X squared minus 2x plus 1 equals 0. Now, this place, we call it the product. This place is the sum. Now, we need two numbers that we can multiply that will give us 1. But when we add it, it will give us minus 2. Forget about the x now. Two numbers that when you multiply to give you 1, that's why you are seeing product here. When you add it, it will give you minus 2. Now, there are different numbers. 1 times 1 will give us 1. But you need to consider the sign. The sign that I mean here is the negative and the positive. Consider the sign before picking any numbers. The sign will tell you how correct you are. So if you have minus 1 multiplied by plus 1, that will be minus 1. If you have plus 1 multiplied by minus 1, that will be minus 1. Already know that minus times minus equals plus. Plus times minus equals minus. Minus times plus equals minus. Plus times plus equals plus. So minus 1 multiplied by minus 1. Minus times minus is plus. 1 times 1. So you can see that this is what will work. So if this is what will work, what do we do? You have x squared minus x plus 1 equals 0. These two, we've not changed anything. Minus 1x and minus 1x will give you minus 2x. Then you separate them. So what's common here? X is common. We have x minus 1. What is common here? Whatever you get in the second bracket must be the same with what is here. So what is common here? Minus is common. Minus 1. When you bring out minus 1 here, this one will be left with x. When you bring out minus 1 here, minus will affect this plus. It will turn into minus. So you have, now you can see we are having the same thing. So it will be x minus 1 equals 0. Then x minus 1 equals 0 twice. Why did I write twice? It's the same thing. It's appearing twice. So we have x equals to, when you bring minus 1 to this side, it will be plus twice. So that's our answer.